Okay, so hopefully you've recovered from my last screencast on the double angle results. Okay, this is going to be much more straightforward. And first thing I'm going to say is that all these results are on your formula sheet, on your information booklet. So just to summarise, what we've established so far is that sine 2 theta, the double angle result for sine, is equal to 2 sine theta cos theta. Right, there we go. That one's pretty straightforward. Just one result for sine 2 theta, and there it is. That's on your formula sheet. Now, for cos 2 theta, now that is equal to, there's three results for it. I reckon it's easiest to start with cos squared minus sine squared theta. Okay, that's result number one. Now, if I make cos squared theta equal to 1 minus sine squared theta, which we all know to be the case, I could write this as 1 minus sine squared theta minus sine squared theta. So therefore I get the 1 minus 2 sine squared theta. Right, so that's result number 2. That's 1. That's result number 2 for cos theta. Now if I go back up to 1 and make sine squared theta 1 minus cos squared, I can say that I've got, if you follow me, I've got cos squared theta minus, rather than sine squared, 1 minus cos squared theta. If we run that negative through here, we end up with cos squared theta plus cos squared theta, hence the 2 cos squared theta minus 1, and that's our third result, and they are, right, 1 result there, 2 result, 3 result, okay, for cos 2 theta, and just a single result for sine. Now we wouldn't want to leave tan out, would we? So tan theta, as you are no doubt aware, tan 2 theta will equal sine 2 theta over cos 2 theta. Now let's just use the sine 2 theta result here. That's 2 sine theta cos theta over the cos 2 theta result. Let's go with this one, the top one, cos squared theta minus sine squared theta. That's nice, but we can make it better by dividing all the way through by cos squared theta. I'm going to do that now. 2 sine theta cos theta divided by cos squared theta will give us 2 tan theta. I'll show you why that's the case. I was just going to write that down, but perhaps that's not a great idea. I'm going to divide that by cos squared theta. Now the bigger fraction is cos squared theta over cos squared theta. I'm dividing through by cos squared theta. Remember, every term. This is a perfectly legitimate thing to do. Okay, now look at this. I cancel that squared with that, so I end up with 2 sine theta over cos theta, which we all know to be 2 tan theta on top. Cos squared theta over cos squared theta is 1. Sine squared over cos squared is tan squared theta. So there's my result for tan 2 theta. Lovely. How many trig results can you cope with? There we are. So the double angle results for sine, cos, and tan. Excuse me. And then we just go to using those. So I'm going to look at a couple of examples. Again, I'm going to pinch them out of the textbook, work them through. This is on page 458, and we're going with given that. So example. All right, given that sine x equals 3 over 4, right, and we're going between 0 and 90 degrees, find the exact values of, firstly, cos x. Right, cos x. Okay, well, I like to write a little picture here. So sine x is 3/4. So I like to do a little right angle triangle, and there's my x, and I'm just going to say if sine x is 3/4, that's my opposite over hypotenuse, isn't it? 3/4. That's what I've got written there. So I can find cos x by finding this side here, because cos x will equal this side over this side. I can use Pythagoras. Square that 16, square that 9, so this must be square root of 7. think of that, squared 7, that squared 9, that squared 16, perfect. So cos x will equal square root of 7 over 4. Now square root of 7 over 4, is that positive or negative? We're in the first quadrant here. Everything is positive in that quadrant, so it will be the square root of 7 over 4 as my result. I could, however, have used, or method 2, I could have used sine squared x plus cos squared x is equal to 1. I know what sine x is, it's 3/4. I can square it to get 9/16. I don't know what cos x is, that's my job. So I can do a bit of algebra on this. I've got 7/16 now, and I take the square root of both sides, so cos x is equal to square root of 7 over 4, and it's positive because I'm in the first quadrant. So either method is good for that. Okay, part B, find sine 2x. B, sine 2x. Now what's sine 2x? Sine x is 3/4. Sine 2x I know to be 2 sine x cos x. Right, so this is how we use the double angle formulae. So I straight away convert it to 2 sine x cos x because I know what sine x and cos x are. Sine x is 3/4. So it's 2 times 3/4. I know what cos x is now. It's root 7 over 4. So I can just work that through to get 6 root 7 over 16, or 3 root 7 over 8. So that'll give me sine 2x. I can go and get cos 2x as well. That's part C, because cos 2x is equal to cos squared x minus sine squared x. And I know what these are now. Cos x is root 7 on 4, so this cos squared will be 7 over 16. Sine x is 3 over 4, so that will be 9 over 16. So that will be minus 1 over 8 cos 2x, which is correct. And then part D, tan 2x. Tan 2x, that's equal to sine 2x, so that's just be 3 root 7 on 8. 3 root 7 on 8, and we're going to divide by cos 2x minus 1 over 8. So it's 3 root 7 over 8 times minus 8 over 1. They'll go, and we're just left with minus 3 root 7 as my result. Okay, that's example 7. Just have a look at example 8. I think we're just looking at a different quadrant here. So this is example 8. We're looking at another example. So given that cos theta equals 4/5, and importantly we're now between 3 pi on 2 and 2 pi, so that's, sorry, I comma there instead of doing an inequality. So we're now, not equal to those, but there you go. We're now in this quadrant here. So cos theta is 4/5. Cos is positive in that quadrant, so that's okay. Given that that's the case, find the exact values of. Okay, so let's have a look. We're firstly looking for sine theta. If cos theta is 4/5, what's sine theta equal to? Again, we could use the little triangle. I don't know what your preference is here, but cos theta is 4/5. I like making a little triangle. I think it's probably the easiest for me anyway. I'll put 4 down there and 5 down there. I know that's 25 and 16, so this must be a 3. So straight away I can see that sine theta is 3/5. It's in this quadrant here though. Sine's negative in that quadrant, isn't it? So sine theta will equal minus 3 over 5. It's in the negative quadrant. Important to pick that up. And B, cos 2 theta. Let's figure out what cos 2 theta is. Right, well, cos 2 theta we know to be cos squared theta minus sine squared theta. I know what cos theta is. It's 4 over 5, so I'm just going to square that. 16 over 25. Sine theta I know to be minus 3/5. So I square that to be 9 over 25. So I've got myself 7 over 25 for cos 2 theta. And we're all good. So I think now we're ready to go. I've spoken for long enough, and the work requirements from exercise 13E await. So have fun with that. We'll do that in class tomorrow.